Okay, let's continue where we left off last time and take a look at these two yield measures. There's yield to call and yield to put. First, with the yield to call, we're going to assume a bond with a 7.5% coupon rate matures in 12 years, but it's callable in 4 years at 104, and that is a percentage of par. The bond is currently priced at $1097, so $1,097. In Excel, we're going to calculate this with 4 times 2 periods. So we're going to assume that the bond gets called in 4 years. So there's going to be 8 semi-annual periods. The periodic payments are still going to be the $75 annually. Divide that by 2 to get the periodic cash flow, the periodic coupon payment. Our price is negative $1097, and the future value now is going to be different than for a normal bond calculation. We need to change the future value because it's callable at 104% of par, so the price, that future value, needs to be $1,040. I kind of misspoke there. That's not the price, that's going to be the call amount, the future value that we get when the bond is called. So the price is $1097 today, but it'll be called away at $1,040. So if we stick all that stuff into Excel, make sure we multiply it times 2, we would get a yield to call of 5.66%. Now if you did the yield to maturity for this bond, it's going to be a different number. The yield to call is what we're concerned about, and it's 5.66%. In a calculator, we would have a very similar type of setup here. We got N equals 8 periods, 4 years times 2 periods per year. The present value is negative $1097. The payment is 75 divided by 2. The future value, again, is a special case because it's called away at 104% of par. It's not going to be $1,000. It's going to be $1040. We compute the interest rate, the periodic rate. We need to multiply it times 2 to get an annualized rate. That would be a nominal rate of 5.66%. A yield to put is very similar. We got a bond priced at $955, 2.5% coupon, matures in 9 years. The bond has a put provision that allows holders to sell the bond back after 4 years at 100% of par. So the question is, what is the yield to put? In Excel, we would just use the 4 times 2, so 8 periods until we can put the bond back to the seller. 25 divided by 2 is our periodic cash flow. That's the periodic coupon payment. Negative $955 is the price. $1,000, so 100% of par, is the future value. We get that result, multiply it times 2 to get a yield to put of 3.72%. In a calculator, again, N equals 8, 4 times 2 periods. The present value, the price of the bond, is negative $955. The payments are 25 divided by 2. Future value is $1,000. We compute the I, make sure we multiply that result times 2, and we get 3.72% as our yield to put. All right, let's keep moving here and look at a yield for a portfolio. So this is a very important idea here. To get the yield for a portfolio of bonds, a collection of bonds, we're not going to simply take the weighted average of the individual bonds. That would give us an inaccurate answer, a wrong answer. So what we're going to do here is compute it just as we would with any other investment. We're going to look at the size and the timing of the cash flows. We're going to find the discount rate that makes these equal to the price of those cash flows, the present value of the cash flows. So once we find that discount rate, that is by definition the yield. And so let's look at an example here. We've got 4 bonds in our portfolio, each with maturities ranging from 1 to 4.5 years. The coupons, the current values, and the individual yields are listed. So we got bonds A, B, C, and D. The coupon rates are listed here. The par value indicates that we've got that many bonds. It's not that a bond, let me rephrase that. That's not saying that bond A has a $3 million par value, but we've got enough bonds to give us $3 million of par value for that bond A, that issue. The price, these are all expressed in percentages of par. And then the yield to maturities I've calculated and put those in there. It would be a good idea, I should say, for you to just put these in, calculate the yield to maturities, make sure you are getting the same answer as I do as a way of checking yourself, checking your understanding of how to calculate these yield to maturities. I want to go to Excel and take a look at calculating the yield for the bond. So let's look up here. I've got all the information in here. The thing I've added here with the value, this column, is I've taken the par value, multiplied it times the price. Again, that price was expressed in percentages of par. So I need to take that result of multiplying the par value times the price, divide it by 100 because it's in percentages, and I would get the current value of bond A at $2.959 million. Do that for each of the 4 bonds, and my total portfolio then is worth today a little bit over $15,609,000. I've got the weight of each of these bonds in my portfolio. Obviously these add up to 100%, so if I add up each of those pieces I would get 100%. The weighted average is just taking the weight times the yield to maturity, and I want to show you that the weighted average for the portfolio bonds is going to be the sum of those products, the sum of the weights times the yields. And if I just did that really straightforward simple calculation, I would get a weighted average yield of 4.482%. What I want to show you is that is not correct. Down here I'm figuring out the cash flows for all of my bonds individually. So each column represents a bond, each row represents the payment at those particular periods. So for bond A, it's lasting 4.5 years, so 9 periods. I'm getting coupon payments each of those periods, and then the very last cash flow at time period 9, I'm getting the par value of $3 million plus that final coupon payment of $52.5. Now, where am I getting the coupon payment? Let's just double check the math there. I'm taking the coupon rate, multiplying that times the par value, and then I'm going to divide that by 2 to get the periodic cash flow. So in this case, it's going to be 3.5% of $3 million, divide that in half, and I would get $52,500. That's going to be the case with each of these bonds. I'm taking the coupon rate, multiplying it by the par. That's how you figure out what the coupon payments are going to be. And then I need to divide that by 2 to get it to be semi-annually. So each of the terminal cash flows, each of these very last cash flows are going to be simply the sum of the par value that you collect at maturity and the coupon payment, that periodic coupon payment. Now this portfolio is the critical column. That is simply the sum of each of the 4 bonds in our portfolio. So if we look at each of these cells here, it's just going to be the sum of bond A, bond B, bond C, and bond D's cash flows in that particular period. So you can see they're kind of bouncing up and down as we move through the different maturities for our bonds. And the yield for a bond portfolio is just going to be finding that rate, finding the internal rate of return of the series of cash flows. So my value today is $15,609,000. We calculated that up here. And if I set that as basically time period 0 and then march through every one of the other periods and I solve for the IRR here, by the way, I do need to multiply it times 2 because the result of my IRR calculation is going to be a periodic rate, a 6-month rate, and to annualize it, get a nominal IRR, get a nominal yield, I'm going to multiply that times 2, and my result would be 4.102%, which is quite different from the 4.482% in the weighted average calculation up here. So this is how you'd calculate the yield for a portfolio, and we're going to stop here and we'll pick up in the next video with looking at the sources of a bond's returns.